In this video, we will take a look at equations. Though they are not quadratic, they are in a quadratic form. What's that mean? So, let's take a look at an example. Here we have x to the fourth minus 8x squared minus 9x. Obviously, this is not ax squared plus bx plus c equals 0. But if we examine this x to the fourth, what squares to give x to the fourth? So, what squares to give x to the fourth? X squared. So, that being said, let's do a substitution. Let's change our variables. Let u equal x squared. Then u squared would be x squared squared, which would be x to the fourth. And our original equation, well, instead of x to the fourth, we could write u squared minus 8. Instead of x squared, we can write u minus 9 equals 0. Now we can solve u squared minus 8u minus 9 equals 0 through any of the methods that we've learned up to this point. And it turns out this factors. So we can write u minus 9, u plus 1 equals 0. So those two things multiply to give 0 as long as at least one of them is 0. So u minus 9 equals 0 or u plus 1 equals 0. This tells us that u equals 9 or u equals negative 1. But you'll remember this problem was in terms of x, not in terms of u. So if u equals 9, what's that tell us? Well, what was u? U is x squared. So this really is x squared equals 9. And likewise, u equals negative 1 means that we have x squared equals negative 1. Now we can solve x squared equals 9, and we can do that by way of the square root principle. So let's take the square root of both sides. So we have plus or minus the square root of 9, which is plus or minus 3. X squared equals negative 1 would be plus or minus the square root of negative 1, which would mean x equals positive or negative I. In this problem, though, you'll notice that we were told to find the real solutions. So that means that we don't need to find the plus or minus I. Our solution is just positive or negative 3. And we can substitute this into the original equation to be sure. Put in 3. We get 3 to the fourth, which is 81, minus 8 times 9 minus 9. That would indeed equal 0. 81 minus 72 minus 9 is 0. And if we substitute negative 3 in, we would obtain the same thing. Looking at our next equation, we can do the same thing. If we look at our first term, we have x squared plus 5x all raised to the second. So this tells us that we're going to let u equal that, x squared plus 5x. So our equation would be x squared plus 5x squared. That would be u squared plus 2, and x squared plus 5x is u, minus 24 equals 0. So again, we can factor this. We have u and u. Don't forget the equals 0. Negative 24 will mean that we're going to have different signs because it's negative. And then let's look at plus 6 minus 4. So u plus 6 equals 0. Or u minus 4 equals 0. This means that we have u equals negative 6 or u equals 4. But we know what u is. If u equals negative 6, that means that we have x squared plus 5x equals negative 6. That's x squared plus 5x plus 6 equals 0, and that factors. And so x equals negative 2, or x equals negative 3. But that's if u equals negative 6. What if u equals 4? We would have x squared plus 5x equals 4. To solve this, we will use the quadratic formula. It will not factor. So negative b will be negative 5 plus or minus the square root of b squared minus 4 times a times c, all over 2a. So that yields negative 5 plus or minus the square root of 41 over 2. So that's real, or actually those, there are two solutions there, are real, and those are real. So we have four solutions. They are x equals negative 2, negative 3, and also negative 5 plus or minus the square root of 41 over 2.